So this one here, what you would wind up with is, well, we need to figure out what two quadrants are sine positive. Sine's positive in the first, and it's positive in the second. And then you have to think about what angle gives you a 1/2 when your opposite is 1 and your hypotenuse is 2, 30 degrees. So you know at a 30-degree angle, it's 1 and 2. So theta would be 30 degrees. What is its radian? Pi over 6. So we know it's going to be at 30 degrees and pi over 6. And then when you bounce that into the second quadrant, come up 30 degrees, it would be at 150 and 5 pi over 6. Remember, your reference angle will bounce you up off the x-axis. On this side.
So it's like the whole section.
Yeah. Well, you don't need to memorize them because you use the reference angle. It's just 1 up from pi. What's 1 up from pi? What this is showing, it asks what are two solutions where sine of theta is a half. So sine being positive has to occur with the first and second quadrant, because it's the y value. What angle for the triangles gives you a sine value of 1/2? Remember, sine's going to be opposite over hypotenuse. So that means it's going to be a 30 degree, 1 over 2. So 30 degrees is pi over 6. Reference it to the second quadrant, you come up 30 degrees. So you come up from 180 to 150. Come up from pi to 5 pi over 6. That's all it is. Okay. And it works for any one of the angle thetas they give you, for whether it's cosine of root 3 over 2 or whatever it might be. So, and so on from there. Okay. All right, let's talk about graphing. So what I want to do here today then is start with 4-5, and I'm going to go real basic as far as graphing sines and cosines. Like I said, I may or may not get to tangent. If we do, cool. If we don't, no big deal. Don't worry that this will not be there tomorrow, but I figured might as well do this today. We can quiz tomorrow, then on Friday we can start talking about the shifted graphs of sine, cosine, and tangent. We probably won't get to all the other inverse trig functions until next week. So we'll build with this. So sine and cosine. Generic form, A sine B times X, and then A cosine B times X. And what I want to do is think about the sine graph first, where A and B will both be 1. So what I want to do is look at y equals the sine of X. And when I do this, I'm always going to graph in radian form. When you guys first learned graphing sine, cosine, and stuff like that last year, you started to do that via the quadrantals, because the quadrantals gave you very easy ordered pairs to work with. At 0, the ordered pair was 1, 0. At pi over 2, it was 0, 1. At pi, -1 and 0, and then 3 pi over 2, you're back at 0, -1, then you wound up back at 0. So going all the way around the circle was 1 period. 1 full revolution is the period. It takes it to go full circle. Sorry. So what we do then, split this. What we do then is we look at the graph of sine. When you're looking at sine value in terms of the y's here, it's in terms of its value, it starts at 0, it goes to 1, goes back to 0, goes to -1, and then goes back to 0. In the time that it does that, it goes from 0, pi over 2, pi, 3 pi over 2, and then 2 pi. So you start at 0, you end at 2 pi for 1 revolution. One time around goes from 0 to 2 pi. That would be your standard period. Okay? To go around the circle. What's halfway between 0 and 2 pi? What's halfway between 0 and pi? And then between here would be 3 pi over 2. So what those are our critical points, our critical values, where it's changing direction, where the easy parts are defined. What is as large as sine grows? What's the biggest value? Yeah, and what's the smallest? -1. We call this the amplitude. The highest value can be is 1. The lowest value can be is -1 because our A value in this case is 1. So according to our unit circle, sine starts at 0 where? 0, it's at 0. At pi over 2, what's the value of sine?
0.
Pi over 2, it's at 1. At pi, what's the value of sine? 0. And look at that. And you get this fancy curve. That curve would just be continuous on and on, depending upon how many times you're revolving around the circle, depending upon what they're setting it for the number of times to oscillate, if you will. Okay. Now, what changes with cosine, using the same period, the cosine value doesn't start at 0. Where does the cosine value start at? It starts at 1, then it goes to 0, and it's just, cosine is just a shifted sine graph by pi over 2. Did you know that?
I do now.
And knowing's half the battle.
Usually, the more you know.
You didn't know that reference?
No. Was I supposed to?
Yeah.
No.
Was it?
G.I. Joe, Yo Joe, and knowing's half the battle.
No. I apologize.
You should. You should be very sorry for yourself.
I,
So cosine then, we'll put in blue. At 0, it's at 1. At pi over 2, it drops to 0. And it goes to pi. You get something like that. Graph papers for the week. No, sleep is important. I like a good thing. I like a good go to bed early sometimes. It's fun. Okay. So the idea here is that the sine and cosine graphs are based off the quadrantals, the values of 0, 1, 1, 0, -1, 0, 0, -1. Those 4 values, the quadrantals, shows you the oscillation of a sine or a cosine graph. It shows you how it curves itself through. The only thing that changes these graphs is going to be the value of A, what we call the amplitude, the height at the height at which it can reach, or the value it can fall to, or the B value, which changes the period. The period can change to oscillate more rapidly or slowly, depending upon what the B value is. Now, the way I usually do sine and cosine graphs, those guys that had me last year know that I just draw this little T-chart and I use it over and over again. I try not to overdo it. I have to double check with Fontana, but when I was reading the book through a lot of times here, the book likes you guys to graph 2 periods of these functions, as opposed to last year when we did it, we usually just graphed 1 period. So we'll see how it goes and build off of that. Today I think we'll just probably just do 1 period and call it and see how we do. So let's define the values of A and B versus the graphs for sine and cosine. Are we okay on this? Does this kind of ring a bell?
Yeah.
Get it, the bell, because it's the sine, sound curve, sound waves.
I get it.
Nope.
You said that to Miss Regina.
That's about.
I did.
That was because he was actually trying.
Generic form again, A sine B of x. The only real different thing that you're gonna see this year versus last year with the values of B is that they will throw the co-functionality angles at you for the negative B. Last year we did the absolute value. This year they'll throw the co-functionality at you. We won't do any of that today, but when we start doing some of the shifting things, we'll bring that back into play. So your value of A stands for your amplitude. How high or low it goes, the peaks and the valleys. The B value allows you to figure out period. And this works for either one of them. Okay, this is going to work for either one, sine or cosine, and it'll work for tangent as well. Do you vaguely remember how to find the period?
Something divided by something.
Something divided by something, correct.
If you're a two,
It's 2 pi divided by
B.
B, because B is used to divide period. Yeah. Well, you guys were close. So period is found by 2 pi over B. Last year we said it was the absolute value. This year we'll throw some of the co-functionality at you, but not today. So you won't have to worry about that. Okay.
Your tie's moving to the side a lot.
I've noticed that. It's a little crooked. I don't know. It might
Maybe
have.
you tie it from.
Might have.
You don't wear clip-on ties? I'm kidding.
Do you tie them?
Zip up.
No, mine is zip tied. Still clips are closed.
Yeah.
Well, like I didn't use like the big one, the cheater ties.
It literally does.
No. Anyway, so what we want to do here is basically it's just going to be listing out what your A and B values are, list out what your amplitude's going to be, list out what your period is going to be prior to figuring out those critical point values. Okay. And those critical point values, if you recall from last year, were kind of a bit of a pain. But if you think of it in terms of what's your ending point, cut it in half, and then find the midpoints, it's not as terrible. So let's do an example. Y equals 1/2 sine of 2x. And let's graph one period of this. We'll start with just one period stuff. So y equals 1/2 sine of 2x. Well, what's my A value? So what's my amplitude? Now, last year we did the absolute value of A. Remember that?
Yeah.
Now, the A value tells you where to start. Start positive or start negative. Your amplitude will always be the positive value of it. Remember that?
Sure.
Okay. What's B?
2.
But
2 pi.
So your period then is going to be 2 pi over 2. So it is pi. How are you? It doesn't get
Do you have any like videos or anything about
Well, I'm doing it now.
this? No, I don't know.
Oh, like funny videos? So we know that our period is pi. So we just put our period out at the end. We always start with that first, put that at the end, because that's where we have to finish up. We put our 0 where they meet. Well, what's halfway between 0 and pi? Pi over 2. Halfway between 0 and pi over 2 would be? And then in here, 3 pi over 4. Those are our critical values. What's the highest value this will reach? And what's the lowest value it will reach? Now, a lot of these graphs are going to look exactly the same. Because I don't want you guys to scale them to look smaller and this and all that other junk. There's no point to it. I want you guys to be able to visualize and see where all these breakpoints go because it's kind of the same thing over and over. Okay? So sine graphs, where does the sine start at? Does it start at 0 or does it start at its amplitude? Starts at, I'm sorry, not amplitude, it's A value. So it starts at 0, goes to A, back to 0, opposite of A, back to 0, and la da 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 da. There you go. Quiz. Oh, the shift? Well, we'll probably do tangent first. We'll probably just do the tangent graphs first, because those can be kind of messy with getting all the asymptotes. We could, but then they probably take away my teaching. And I have 2 small children that don't. You like that? Oh, sorry, did I go too fast? I'm sorry. Cosine? Let's do a cosine. Yeah. Tangent to the asymptotes. Oh, yeah, let's do it over there. This is your stuff, yeah. All right, let's do we okay? Cosine. Oh, and those guys thought they were so clever with their saying they gave you.
Mark, you do that. I didn't.
What is it? I don't get it. Like, what happened over there?
It's an 8.
Where's your 8?
Don't try so hard. Anyway, so again, in this case here, we start with what's your A value?
5.
What's your B value?
2/3.
Therefore, your period is going to be 2 pi divided by 2/3. Very good. So your period becomes 3 pi. Okay with that?
Sure.
Let me ask you this real quick. What would change if I had A value at -5? Where would the graph start? At the bottom and work its way up. Okay, just want to make sure if you guys remember that. So we start with our graph. What's halfway between 0 and 3 pi? 3 pi over 2? What's half of 3 pi over 2? What's 3 halves times 1 half? 3/4. Huh, go figure. Now, what's halfway between 3 halves and 3? Think of it in terms of 2s. What's halfway between 3 over 2 and 6? Where would it be? 6 over 2. What is it? Did I say 3? Wait, 6 over 2 is 3. Yeah, so it'd be 6. What's halfway between 3 and 6?
No.
5.
Okay.
4.
This is why we need calculators.
All right. Instead of trying it that way. You guys like money, right?
I love what's mine.
Okay. So if I have $1.50, I know, big shooter, and you have $3, what's our average?
Some money.
450 divided by 2,
25.
More money than I have now.
225. Okay. So 225. But
I don't think you're getting anywhere. You're just making it harder.
225 just made it worse.
225 is, well, it's 1228. 225
Ha, ha.
is 2 1/4, right?
Yeah.
Yeah.
Usually low.
So is it
Nine.
904?
Thank you!
I still don't get it.
No, I
It
get
works.
it now.
Because if 3 over 2 is 6 over 4,
I know.
half of that is 3 over 4, then 9 over 4.
Then 904.
I just crap out of that point. Yeah, just get better at math, would you guys please? No, seriously.
I'm in pretty now.
That's
Yeah.
really what he was thinking, and Mr. Murphy.
Okay. You could use a calculator if you had to, right?
I probably wouldn't
You
know how to
probably,
do it.
can you find the, you wouldn't press pi button, you would just take 3 plus 3 over 2, hit enter, cut it in half to get the fraction. And
Yeah.
there's your answer.
So we probably won't get calculator graph.
Anyway,
We get like dopey calculators.
I know. I would give you a dopey calculator, yes. So what's the highest value this is going to reach?
5.
And what's the lowest value?
Negative 5.
Now, cosine, does it start at 0 or does it start at its a value?
Hey.
Hey.
Oh, that's a
Check your freaking
Oh, shoot.
All right, start with the negative and see how we do. We okay? Can I go another one?
Yeah.
All right. Y equals negative 2 cosine pi over 4x. What's your a value?
Negative 2.
B value is pi over 4. Period then.
Eight.
8.
Wait.
math.
Oh. Oh, yeah.
Multiply by the result.
And then the lines cancel out.
And then you get
There you go.
ASC.
So you have a period of 8 and an a value of negative 2. What's halfway between 0 and
I got
8?
this one. 4.
Four.
I like
And then 6 and then 2.
No, and then 2 and then 6.
What's the highest value this goes to?
2.
And what's the lowest value it goes to?
Negative 2.
Where does it start?
Negative 2.
Good.
Stop. Everyone stop.
Really straight lines.
I hate you all.
That's a air 5 for support.
No, her lines are, they're like lines, not.
Don't
curves.
judge people's lines.
Like,
Not everyone's an artist.
well, I definitely am not either.
Well then,
That's the way you talk.
those who live in glass houses
Yeah.
shouldn't throw stones.
Or change
Yeah.
it.
My mom used to tell me that, but not anymore.
Maybe she still
Really?
should.
She used to
Feel
tell
free
me
to use it.
not put all my eggs in
But you're
in one basket or eggs, something, I don't know.
Don't-
Does it look better? Does it look better now? You guys happy? I want to conform to you, so I'm erasing.
Here, that's the answer I was making. The answer is yes.
Very interesting. If you buy them now, and it's the worst thing ever. Yeah,
All right.
and now it's death.
Oh, I thought we were gonna do other stuff. Homework. This is depressing.
Mr. Murphy, I never. I almost asked you how your weekend was, but yesterday was only.
Wish it was.
Right. We'll go through those. We'll talk about this stuff on Friday. And then Friday we'll talk about tangent and maybe start shifting some tangent and maybe a little bit of shift at sine and cosine. The idea when we start shifting stuff is that we're still going to do those parent functions, and then we're going to add the h's and k values to them. I know that the way we did it last year is kind of the same thing that I like to do here, because it may take a second or two longer to do it, but it kind of forces it to work. That'll get us to next week. Next week, then we'll have pretty much the bulk of the week. We'll work on the inverse trig functions, where we're going to graph cosecant, we'll graph secant, and cotangent. Believe it or not, it's actually pretty simple to graph cosecant, secant, and stuff. For example, if you're thinking about just what a sine graph is between 2 pi so a sine graph goes from 0 to 1 to 0 to -1 to 0. That would be a sine graph. Okay? This cosecant graph would just be the inverse of all of those values. What's the inverse of 0?
0.
Undefined.
Oh.
So it's an asymptote. What's the inverse of 1? 1. What's the inverse of 0? What's the inverse of -1? What's the inverse of 0? What'll happen is we're going to look at the two other values and rotate this way. That's cosecant. Cosecant would be in the blue. It's just the reciprocal properties of sine. Same thing with cosine. If I did the cosine graphs, I would just reciprocal property all the other ones. It is just this graph shifted pi over 4. That's it. Cotangent, same deal. You're inversing the tangents. It just thinks just the asymptotes. You just create asymptotes and move things around. That's all. It really isn't tough. We'll still do all this way. If there's a shift involved, we'll do the parent function, the shift, and then we'll flip it on the inverse values, because we can see where things are going to go, where their critical points are. All right? So it looks like it's going to be really weird, but it's kind of the same process over and over again. Other questions at all? Yay!